Is it visible? This question is visible to all of you? Is it
Yes, sir.
visible?
Yes, sir.
Yes, sir.
See, it is better if you put on your cameras because I can interact with all of you. Okay. Kripagara, Chinmay. So I think this question is visible to all of you. Is it visible?
Yes, sir.
Yes, sir.
Okay. So could you try this question? A mixture of sodium hydrogen oxalate. Okay. And this is another compound is an addition compound. Okay. Potassium hydrogen oxalate dot. This is oxalic acid. Required equal volumes of 0.2 normal KMnO4 and 0.12 normal NaOH separately. What is the molar ratio of sodium hydrogen oxalate and this compound, this addition compound? This is the question in the mixture. So, will you try this question or shall I discuss? Let me discuss this question. Later on, I will give similar type of question which was asked in IIT. That question you can solve. So let me discuss this question first. So first of all, if we consider this compound sodium hydrogen oxalate and another compound, so these two compounds, they're reacting with equal volumes of, suppose V liter 0.2 normal KMnO4 and V liter of 0.12 normal NaOH. Now they are asking what is the molar ratio. Means suppose this is A moles and another compound that is B moles. So what is the ratio? A is to B. That they are asking. Right? To solve such kind of questions, first you see here KMnO4 is what? KMnO4 is an oxidizing agent. KMnO4 basically oxidizing agent. So in this case, KMnO4, the reaction with KMnO4 with both of this will be redox reaction, right? But here NaOH is what? A base. So the reaction with NaOH, that will be not a redox reaction. That will be acid-base neutralization reaction. That you have to keep in mind, right? But in both the cases, reaction with KMnO4 and this NaOH, reaction with NaOH, in both the cases, we can use the law of chemical equivalence. Law of chemical equivalence we can use. So, see, according to this law, if I consider reaction with KMnO4 and it is KMnO4 in acidic medium, generally in redox titration we prefer acidic medium. So KMnO4 in acidic medium. So now, according to this law, if I consider reaction with KMnO4 first, according to this, number of equivalents of NaHC2O4 plus number of equivalents of KHC2O4 dot H2C2O4 equal to number of equivalents of KMnO4. First, we have to consider reaction with KMnO4 in acidic medium. So again, according to the law of chemical equivalence, I have written this thing. So in case of NaOH also, same law will be followed, but let us consider first this reaction with KMnO4. So here, could you tell me what is the N factor of this N factor in this redox reaction with KMnO4, sodium hydrogen oxalate? Anyone? What will be the N factor in this case? This oxalate part, here in oxalate part, oxidation state of carbon, that will be +3. So it will be converted to what? CO2. Okay, in redox reaction, oxidation will take place. Okay, so KMnO4 is an oxidizing agent. So here, what will be the N factor for this compound, first compound? Anyone? This oxalate part in such kind of reactions, redox reaction, oxalate part will be converted to what? CO2. So here 2 carbon atoms. So if we consider CO2, so then what will be the N factor? +3 to +4. How many carbon atoms are there in this compound? If we take one molecule, 2 carbon atoms are there. So here N factor will be 2. Are you getting my point, all of you?
Yes, sir.
Yes. Now for this compound, what will be the N factor? After knowing the N factor, we'll apply the law of chemical equivalence. So what will be the N factor for this entire compound? This is an addition compound. Okay. So if you consider this compound, here also oxalate part is there. So now how many carbon atoms are there? 1, 2, 3, 4. Okay. So here, what will be the N factor? Here also the oxalate part will be converted to CO2. Okay, oxalate part, here also it will be converted to CO2. So now here 4 carbon atoms are there. If you take one molecule, so here N factor will be what? N factor will be 4. Are you getting my point?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, from here it is 2, so here 2, here also 2. Now let me apply this law. So here number of moles I have considered A mole, and here number of moles I have considered B moles. So what is the number of equivalents for the first compound? N factor into number of moles. So here N factor is 2 and number of moles, that is A. So number of equivalents will be 2A. And here number of equivalents of this second compound, it will be what? N factor into number of moles. So 4B. That is equal to number of equivalents of KMnO4. Now for KMnO4, we have considered this is V liter. The volume is, that is V liter. And this is 0.2 normal. So volume in liter into normality, directly we'll get number of equivalents. So just we have to multiply V into 0.2. Is it clear? So this is the first equation. Is it clear?
Yes, sir.
Yes, sir.
100%? 100% or 99%? Tell me.
Yes, sir.
Yes, sir.
100%. Okay,
100%.
fine.
Yes, sir.
100% clear.
100%.
So now we'll consider reaction with NaOH. So reaction with NaOH, whenever we'll consider reaction with NaOH will be acid-base neutralization reaction. NaOH, this is not an oxidizing agent. So, but whenever we'll consider acid-base neutralization reaction, in that case, we have to consider N factor. N factor, that is important. Okay. So now, how to calculate the N factor? So this compound, for the first compound, how many acidic hydrogens are there?
1.
One acidic hydrogen is there. So in acid-base neutralization reaction, if we consider reaction with NaOH, reaction with NaOH. So in that case, for the first compound, N factor is 1. And what is the number of moles? A. So this is the number of equivalents. Same law we have to apply. Means the number of equivalents of both, if we combine, that will be equal to the number of equivalents of NaOH in this case. In this case, how many acidic hydrogens are present? Second compound. That will be the N factor. Here one acidic hydrogen, here two acidic hydrogens. Okay, acid base neutralization reaction. So you consider the number of acidic hydrogens. So how many acidic hydrogens are there in this compound? This is an addition compound.
3.
3. Very good. So here number of equivalents in this case, acid base neutralization, 3 into B. And here number of equivalents again, liter, volume in liter into normality. So here 0.12. So this is equation 2. Now you solve this and determine this ratio A is to B.
Sir,
Yes. Yes,
sir,
Mobia.
can you explain the second equation?
Second, okay. With NaOH, the reaction will be what? With NaOH, the reaction will be acid-base neutralization reaction. So we have to consider how many acidic hydrogens are there in this compound. So this is what? Oxalic acid. See, both the here, actually this is an addition compound, dot is there. So two compounds are joined together, right? So now here, this is oxalic acid part. So here two acidic hydrogens are there. And here one acidic hydrogen. Okay, oxalic acid is this, like this. So how many acidic hydrogens? 2. And this is what? This is potassium hydrogen oxalate. Means this type of compound, this compound. Okay, and both are combined here. This is an addition compound. So you see how many acidic hydrogens are there? Total 3 acidic hydrogens are there. So here N factor is 3. Clear? In acid-base neutralization reaction, basicity you have to consider. If any compound is okay reacting like an acid, okay, or base, in case of acid we have to consider the basicity. Got it? Mopia, is it clear?
Yes, sir.
Okay, so solve this and what will be the answer? A is to B. Kripagara, Chinmay. You can solve it very easily. Just solve it.
1 by 11.
1 by
11.
huh? You see the options. You see the options. Mopia, calculate. You can solve it very easily. Nothing in it. Okay, so this is entered. This thing is 3 by 5. So just solve it 5A.
The 3:1.
See what is coming out. Check it out. 3B. So they are asking A is to B. Okay, So it will be what? 3:1. Correct?
Yes, sir.
Yes, sir.
Got it? Okay. So I'm going to this type of one question, and this type of question they have asked already. I'm just telling you. I'm just showing that question. See this question. Read this question. This was asked in JEE. Here you see this question. It seems that this question is lengthy, but actually the basic core concept is same. A mixture of H2C2O4 and similar type of question and NaHC2O4. The total weight, that is 2.02 gram, was dissolved in water, and the solution made up to 1 liter. So this 2.02, that is in 1 liter. That is in 1 liter. 10 ml of this solution, we have taken out 10 ml from this. 10 ml of this solution required 3 ml 0.1 normal NaOH for complete neutralization. In another experiment, 10 ml of the same solution, 10 ml of the same solution in hot dilute sulfuric acid medium require 4 ml 0.1 normal KMnO4 for complete reaction. Calculate the amount of C2H2O4 and NaHC2O4 in the mixture. This is the question. Got it?
Yes, sir.
Now I am telling you one thing. Just I am telling you one thing. The basic approach is that is same. The basic approach that is same. Here you do one thing. They have given 2.02 gram. Okay. So you can solve in a very simple manner. Means suppose you can consider here okay, this is X mole and this is Y mole, like this also you can solve. Okay, do it. Or in terms of mass also you can solve, no issue. It is up to you. Mass you can consider for one is suppose X, another is 2.02 minus X, then what will be the number of moles, like in that way also you can solve it. Okay, first of all, you tell me in this case when we are considering NaOH, reaction with NaOH, what will be the N factor if I consider reaction with NaOH?
Sir, it will be 3.
Reaction with NaOH for this and this, these two are separate. For this, if you consider reaction with NaOH, acid base
So for
neutralization.
the first one, will it be 2?
Yes, definitely. It will be 2 for the first case. It will be 2. With NaOH, if you consider the reaction, it will be 2 N factor. We are not balancing, just N factor we need 2. For this, if you consider reaction with NaOH, what will be the N factor?
It will be 1.
Absolutely correct. It will be 1. Very good. So, okay, fine. If we consider reaction with KMnO4, If you consider reaction with KMnO4, then what will be the N factor? Then what will be the N factor? Acid-base neutralization reaction. Oxalate part will be converted to CO2. So what will be the N factor?
2.
Are you getting this or not? If I consider reaction with KMnO4, KMnO4 is an oxidizing agent. It will convert this carbon from like +3 to +4. Okay, it will oxidize. KMnO4 will oxidize. So what will be the N factor in this case?
2, sir.
Yes,
Two.
2. Very good. With KMnO4. And for this case, sodium hydrogen oxalate. For this
2,
case,
sir.
it will be
2.
2. Okay,
Also
it will be
two.
2. Very good. Now you can solve, no issue. Solve it. Suppose I am considering this is, let it be A mole. Or X or Y also you can take, no issue. And this is B mole. Okay. So here, if I consider with NaOH, so number of equivalents will be 2 into A. In this case, with NaOH, N factor is 1. So only B, right? If I consider reaction with this. But again, what we have to remember, we are now considering this what? This is for 1 liter. Here, if we have to keep in mind, this entire, this 2.02 gram, this is dissolved in 1 liter. From this 1 liter, we have taken out this 10 ml, right? With this 10 ml, we are considering. Okay, so for that, for 10 ml, what will be the total number of milliequivalents? For 10 ml, what will be the total number of milliequivalents? For 10 ml, total number of milliequivalents will be equal to the milliequivalents of NaOH, right? And this will be what? 0.3 milliequivalents. That is for 10 milliequivalents. Milliequivalents we can convert to equivalents. So this will be 0.3 into 10 to the power -3 equivalent. This is for 10 ml. Okay, so for 1 liter. So for 1000 ml, what will be the total number of equivalents? Tell me. This is 0.3 into 10 to the power -3 into 100. Okay, so it will come out 0.03. So directly I can write here 0.03. This is the number of equivalents. This is equation 1. Here what I have done, for 10 ml solution, number of milliequivalents, just you multiply volume in ml into normality, and I have converted into equivalents. So for 10 ml, number of equivalents is 0.3 into 10 to the power -3. So for 1000 ml, 1 liter, what will be the number of equivalents, right? So now, if we consider reaction with KMnO4, reaction with KMnO4, here what will happen? N factor is A into 2 into A. So 2 is the N factor, number of equivalents 2 into A. Here it will be again 2B. In this case, number of milliequivalents 0.4. So equivalence is 10 to the power minus 3. And for 1000 ml, for 10 ml, this is for 1000 into 100. Second, it will be 0.04. Okay. Now you can solve A and B. After solving A and B directly mole you can solve number of moles A and B. Then you can multiply with molar mass. You will get the amount. If one you can calculate, another just you minus from 2.02, from 2.02 you can minus. Number of moles first you calculate. Okay.
Sir, both will be 0.01.
Answer that will verify the amount you are talking about. Number of moles.
Yes, sir. The value of A and B. Yes.
Value of A and B. Okay, let me check. What is the answer of Chinmay and Kripagara? Now A and B, after calculating this A and B value for any one you calculate. Suppose A for this, so multiply into molar mass and you will get the amount. Okay, mass you will get, and then you just minus from this 2.02 minus W, you will get mass of this. Calculate, and the mass they are asking in terms of this gram you have to report.
Sir, can you tell it again?
Yes, definitely. Suppose I'm just giving you one example. Suppose the mass of, suppose this whatever the answer is coming out, suppose the mole of C2 H2C2O4 oxalic acid, the number of moles, suppose 0.2 or whatever you are calculating, suppose 0.2 I'm considering. So when you convert mole to mass, just multiply by molar mass. Okay, molecular weight in gram, just you multiply. Calculate the molecular weight. Molar mass means that molecular weight in gram. Okay, so you just multiply that value with this mole, you will get the amount in gram. Mass you will get. Clear?
Yes, sir.
And when mass of one compound you will get, then the mass of other compound you can calculate very easily. Minus that from 2.02. Okay, all of you can rejoin with the same ID, right?